How did you guys define symmetry? Juan, how did you guys define symmetry?
It's the line that divides the graph.
Line that divides graph in half. Thank you. Carla, did you guys think of a real life example of symmetry and not symmetry? Yeah, do you actually know what that is? These are two portable trailers, and they basically took this wall out, and then that's what connects it. Is that interesting? So it's kind of like two trailers. And what was that one? A not example. The flag as it is, or like when it's straight? You're thinking about the designs where the stars are? So they said the flag. Okay, now I want you and your partner to think of a letter. What are you thinking of? Capital or lowercase? Give me an example that is symmetrical and not symmetrical. Ready, set, go. Daniel, where are you? What did your partner say? Lowercase or capital?
Lowercase L, my bad.
Lowercase L. Can you guys pick another letter? Is that for yes or no?
No. Yes or no?
You're saying O is not symmetrical.
I mean for yes.
Symmetry is the mirror, isn't it? And if I put this dotted line where the mirror was, that is symmetrical. Daniel, can you tell me an example that is not symmetrical? You can't cut P in half this way, can't cut P in half this way. Okay. Clarify any questions your partner has, and then now I want you guys to think of graphs. What are you thinking of?
Graphs.
You can look at the previous couple of pages. There are names and graphs that might help you. Take 30 seconds. Ready, set, go. Leslie of the y. Give us the name of a graph that is symmetrical. Quadratic. Good job, Casimiro. And Leslie. You can fold it. Where's my folding line, class? Ah, someone said very specifically, I am picking the y-axis. Okay. Partner B tell partner A, where would the quadratic be if it is not symmetrical? Where would the parabola be shifted to show that it's not symmetrical? Ariana, where can the parabola be so that it's not symmetrical? Oh, so you're thinking cubic. I like that. Let's draw cubic. Can that be folded on the y-axis, class? No. So she is correct. This is not symmetrical. Does anyone know the answer to the one I said about the parabola? As long as it's not on the y-axis, this parabola way out here is not symmetrical about the y-axis. It would have to be directly on the y-axis. Do you see that? Now, although you're saying, like, Mr. Inca, that can push to the other side, that is correct. But what I'm trying to say is this graph specifically is not symmetrical. In order for it to be symmetrical, it has to be on the y-axis. Let's write that as our notes. If it is symmetrical about the y-axis, then this one is called even. And I have a silly phrase. Evenly. And let me explain my silly phrase to help you remember. This graph is symmetrical. What's the folding line called? Class, what is that? Y-axis, look. You fold the line on the y-axis. Partner B explain to partner A evenly. Ready, set, go. Okay, this one over here we said was not symmetrical about the y-axis, but let's cross this off. This one can become symmetrical, but not about the y-axis or line. It can actually be symmetrical about a point. Does anyone know where that point is? Someone said 0. Okay. I have this cheesy thingy. And that's the same graph, right? So let's just use a bigger picture. Not exact, but you get the idea. Where can I put my finger so that I can do a transformation? Someone said 0. Class, should I translate it? No, that doesn't give me the same graph. Can I reflect it over the y-axis? Does that become the same graph? No. Can I stretch it, dilate it? No. Oh, if I put my finger at 0, class, what is this called on the graph? The origin. If I rotate it about the origin, do I get my same graph?
Yes.
Yeah. How many degrees did I rotate it? I went a whole circle? If I rotate it 180 degrees about the origin, yes, symmetrical about the origin, then it is called a odd function. Okay, partner A, summarize even. Partner B, summarize odd. Ready, set, go.